Welcome all, and thank you for joining today's Adabri webinar. My name is Matt Holdstock, and I work in Extension at the Adabri, and I'll be your host for today's webinar. In today's session, we'll be looking at the all-important weather forecast with a high-risk weather season briefing for grape growers and winemakers for the spring and summer of 2024 to 2025. In the spirit of reconciliation, the Adabri would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and the community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. I'd also like to acknowledge Wine Australia for providing funding and support for the webinar program via the Adabri's Communication and Extension project. Before we jump in and make a start, a couple of quick reminders to anyone who's new to the Adabri webinar program. If you'd like to provide a comment or ask a question, please click on the Q&A button. It's on the Zoom toolbar at the bottom of your screen or at the top of your screen. Type in your question and click to send it through. We'll hold the Q&A session at the end of the presentation, but feel free to send through questions at any stage throughout the presentation. A reminder also that this session is being recorded and a link will be sent through to you later via the Adabri's YouTube channel. For anyone who's just joined, welcome. Today's webinar topic is the weather with the title of High Risk Weather Season Briefing for Grape Growers in the Spring and Summer of 24 to 25. And it's a great pleasure to welcome Dr. Janatan Nahar. Dr. Janatan Nahar is an extended prediction specialist at the Bureau of Meteorology. Janatan is a professional hydroclimatologist specialising in climate projection and has more than 15 years experience in climate and the hydrology sector. Janatan obtained her PhD from the University of New South Wales in Sydney, Australia, in climate modelling and drought projection. She also has experience in Australian water assessments, especially for the Murray-Darling Basin. So Janatan, if you're ready to make a start, I'll get you to share your screen. And if you could hand over, and I'll hand over to you.
Thank you very much, Matt. I will share my screen and let me know if it is coming up.
Perfect.
Thank you. Good morning, everyone. I am Janatan Nahar, and as Matt already introduced me, I work as an extended climate prediction specialist in the Australian Bureau of Meteorology. And in my role, I provide climate forecast and analysis to support climate preparedness and manage climate-related risks. So it is a pleasure for me to be here today. So today I will be presenting the climate outlook for high-risk weather season and what we can expect during Australia's severe weather season. Thank you for having me. So as we approach high-risk weather season, which spans from October to April, it is crucial to prepare for heightened risk of severe thunderstorm, tropical cyclone, flooding, heat wave, and bushfire. So therefore, in today's presentation, I'm going to focus mostly on these items. As this presentation is targeted to grape growers, I believe it will help you to plan for the season ahead. I'll start with the recent conditions. So in terms of maximum temperature in last 3 months, which is July to September period, what we have seen, it was mostly warmer than average, and minimum temperatures were also very much above average across the country, almost everywhere. And we already know that August was like record warm for last 110 years. So September minimum temperature was warmest on record for Western Australia. So in terms of rainfall, it was drier than average in the southeast, average to wetter than average elsewhere. Large area in the northwest had above average rainfall. However, this may not be very significant in terms of total because this is dry season in Northern Australia, as we know that winter is a dry season there. So then moving to year-to-date condition. Sorry. So year-to-date rainfall was average to wetter side, pretty much similar to what we have seen for last 3 months. But there was a contrasting pattern in the south, as you can see, like in South Australia, Victoria, Tasmania, southwest of Western Australia, which had very much below average rainfall. Most of New South Wales and Queensland had average, and Northern Territory, Western Australia were wetter than average. So temperature were mostly above average given very warm winter, and it was a record warm winter. So it is understandable the temperature is above average. Then moving to the storage and soil moisture condition, storage across the country are at high levels or nearly full with some exceptions, mostly in the Western Australia, Tasmania, and a few in Queensland. Soil moisture also followed the pattern of rainfall because it is mostly rainfall driven, below average in the southeast and above average in the northwest and average elsewhere. Then we will see some recent extremes that's been observed during August, mostly in August and a few in September too. So, as we can see at the national scale, widespread unprecedented heat at the end of August, warmest August on record. It was nationally warmest August, and also for New South Wales, Victoria, Queensland, Tasmania, and South Australia, almost for most of the states and territories. So, warmest August temperature ever recorded in Western Australia, Queensland, Northern Territory, and South Australia. There were some wind extremes in Tasmania and Victorian part, southern Victorian part of the country during August. And in terms of heat extreme, we can see like a big part in the central Australia, extended from central to the southeast, mostly in the Queensland part, had at least 20 locations recording 40 plus temperature during August. As we know that August is a cool month, a relatively cool month, so it is quite significant. And we have also seen some early season fire in Sydney and Illawarra region, and also a bit of flooding in one or two Tasmanian catchments. From there, we will move to the long range forecast for next coming season. So up to this, it was about what we have observed so far. So outlook for November to February period, and we start with the rainfall. And we will talk about the chances of seeing above median rainfall. Rainfalls are likely to be above average across much of south and east for November to January period. It is likely to 60 to 80% chance that it will be above average for much of southern and eastern Australia and scattered areas in Western Australia and in Northern Territory. For much of Western Australia, the NT and the northern river regions in New South Wales and southeastern Queensland, rainfall is likely to be within the typical seasonable range, kind of like average for the season. And there is an increased chance of unusual high rainfall for much of mainland, with a greater chance for parts of northern Queensland and South Australia. Then we move to temperature. What we can expect in terms of temperature for November to February period. So there is definitely increased chance of unusual warm days and nights across most of Australia. Days and nights means high maximum and minimum. Above average maximum and minimum temperatures are likely. The chances are 60 to 80% across most of Australia. There is also an increased chance of seeing unusual high maximum temperature for most of Australia, with a greater chance for Tasmania and Northern Territory. By unusual maximum temperature, we mean like top 20% of record. Then we move to minimum temperature, and it is similar to maximum temperature, but it seems like the intensity is much higher. There is an increased chance of unusual high minimum temperature across Australia, particularly across the north parts of New South Wales and in Tasmania, where unusual high minimum temperatures are very likely, and the chances is like 3 to 4 times more than normal. Given that we have seen the high possibility of seeing maximum and minimum temperature, what's the possibility of seeing heat wave, as we expect to see high maximum minimum temperatures? So definitely it is high. um, and this is also confirmed from our historic record. So the plot here is showing the number of days when Australian temperatures were in warmest 1% of record. Given the numbers are increasing gradually, general possibility is to see more heat waves. So, what is heat wave? If we go there, a heat wave is when the maximum and minimum temperatures are unusually hot for over 3 days. So, this is compared to the local climate and past weather. So severe heat wave can be dangerous for vulnerable people, and extreme heat waves can be dangerous for everyone. And Bureau issues heat wave warning when a severe or extreme heat wave is forecast within the next 4 days. So keep an eye on Bureau's website for heat wave warning. And we have seen last season in Northern Territory, Queensland, and Western Australia experience severe heat wave events in October, December, and January. And then in mid February, widespread severe to extreme heat wave impacted Western Australia. So, a late summer severe heat wave impacted South Australia, Victoria, and Tasmania in March after a relatively mild summer. So, it seems like the window of heat wave has extended. So this is the extreme heat potential long range forecast for coming weeks until 8th of November. So as you can see, like it is a spring, still spring, and then moving towards summer. So a bit of heat wave chances, elevated chances in the northern part of the country as we move in time. So this will extend more in the south. Then we look at the bushfire condition. AFEC publishes their bushfire outlook for each coming season, and the latest one was for spring. Before going to the spring bushfire outlook, let's have a look at the peak fire danger season for various seasons of Australia. So, October to February is the most critical period for bushfire. For two-thirds of central to southern Australia. So as we move in the south, the season starts later in the year. But destructive and deadly fire can occur anytime during the normal bushfire season across Australia. So the bushfire outlook shows the areas of increased fire risk on the map with red color, as you can see in the map. So according to the AFEC outlook, there is an increased risk of fire for parts of northern Australia and the southeast during spring to November period. So what is the context to this outlook? So August saw widespread, very above average temperature, and that was Australia's warmest August on record. So it's already been warming. For spring, there is an increased likelihood of unusually high maximum temperatures across most of the country, which we just have seen few slides back. And then, although there is an increased chance of above average rainfall for much of eastern two-thirds of the country, larger part of Western Australia have an increased chance of below average rainfall. So those areas will be more in danger. And on top of all this, increased fire risk for southern and central Queensland is driven by the dry grasslands. In northern Australia, unseasonal rainfall in Queensland and Northern Territory had led to increased fuel loads. So the potential for an early start of fire season in parts of South Australia, Victoria and Tasmania if warm and dry condition continues. I will show an example how that works. So the plot here below is showing the starting day of fire season, which is defined by Forest Fire Danger Index, which is an index, and a value of 25 or above is considered dangerous for fire condition. So the trend line here shows over time the first day with FFDI value 25 comes earlier in the season. For example, this is a plot for South Coastal New South Wales. In 1970, if the first day with FFDI index value 25 was occurring in October, but over time, the day with FFDI 25 comes earlier in the season, and in 2010, say, it was in August. So during this time, like a 40 years of time spent, the time has extended from October to August. So that means the fire season length has extended. So these are the other potential influences for coming months when it is about fire danger. So we can see root zone soil moisture is mostly average in eastern two-third of the country. Um, and then chances of unusual high temperature, Tmax is high. And yeah, so recent dry conditions in Queensland and central Queensland and New South Wales, inland New South Wales, which I just mentioned, is already elevating the danger for fire for coming season. So this is AFDRS index based on Outlook, the regional climatology. Fire danger is likely to be above average in the November to January period across parts of NT and Queensland. So this is kind of reiterating what we have seen in last two slides. Then we look at the rainfall deficiency. So rainfall deficiency is a good indicator because it tells us like if the season is already under rainfall stress for prolonged time. So this is observed and forecast rainfall deficiency maps. The lowest decile is called deficiency. For 8 and 14 months period, the deficiency maps are following a pattern. So deficiency was concentrated along in the area of Victoria, South Australia, but gradually deficiencies developed in coastal Western Australia and in Tasmania. But the good thing is by the end of December, we expect to see some relief in rainfall deficiencies as the red area on the map seems like less compared to the observed. Then looking at the root zone soil moisture forecast for next 3 months, it is mostly average. So it is expressed in terms of percent of column. So as we can see, high root zone soil moisture is forecasted for eastern east coast from north to south, especially for Tasmania, and then extended over northern part of the country. This is mostly because the forecast rainfall, as we know that northern part of Australia is going into their wet season. So we expect to see more rainfall and that will elevate the soil moisture condition. That's how over time the blue area is extended in the north. And this is potential evapotranspiration. And for the coming months, high potential evapotranspiration is forecasted, especially in November and then in January. So now looking at the potential for flooding, and we know flooding can happen anywhere in Australia. Rainfall from tropical cyclone almost always cause significant flooding. Last season, significant major floodings were associated with extratropical cyclone that impacted northern Queensland catchments. Widespread flooding also affected large areas in other part of the country, including Queensland, Northern Territory, Victoria, New South Wales, and Western Australia. So depending on where the rain falls, river level can go up and down in a matter of hours or from days to weeks time in more inland river basins. So for the period of November to January, there is an increased chance of seeing unusual high rainfall for much of mainland, as you can see from the map, the green portion, with a greater chance for parts of northern Queensland. And this will influence the flooding potential. Uh, Bureau of Meteorology has a flood forecasting and warning service that provides a flood watch and flood warning for during the flood season. Please keep an eye on Bureau's website and look for flood warning for your region. Then we move to stream flow forecast and root zone soil moisture conditions. So there is a stream flow, seasonal stream flow forecast service that Bureau of Meteorology provides. And that stream flow forecast is telling us that October to December period in the southern part of the country, southeastern part of the country, low stream flow are expected, but in the northern Tasmania, stream flow, high stream flow, and also in the northern part of the Queensland, like coastal areas, we can see high stream flows are forecasted. Next, we move to the topic of frost. So frost can form in two ways initially. So one is radiation frost that forms when the ground and ambient air cools down, and it commonly occurs under clear sky with little or no wind. And radiation frost begins at ground level and gradually it rises to higher objects. And this is the most common type of frost formation in Australia. And then there is another way of frost formation, which is advection, and that type of frost forms from a mass of very cold air, moves over an area and replaces the warm air in that area. But this is not it is and this process is not affected by cloud cover or can occur at any time, day or night. But this is not a very common type for Australia because we don't have that very cold air mass coming down and freezing the temperature. So when we talk about the type, frost is mostly primarily two types: white frost and black frost. White frost is simple water vapor in the air freezes up upon contact of an object, and that has a surface temperature below 0 degree, and then the frost forms. And this is the most common form in Australia that we see. There is another type of frost which is called black frost. Black frost is like interesting, occurs when the temperature drops to freezing point, but the adjacent air doesn't contain enough moisture to form the frost on exposed surface. So this causes an internal freezing of the vegetation, leaving it with a blackened appearance and killing it. This is more dangerous, but this is fairly uncommon in Australia. So, what are the conditions that forms frost that affects? One is cloud cover. Clear sky helps escape radiation, and cloudy sky uh, does the opposite and slows down the process. Humidity, high humidity slows down the cooling process, we all know. So, if the humidity is high, it is better for frost. And then the third is surface wind, which usually works at night, and it can mix the cooler air near the surface with warmer air just above it and reduce the potential of frost. So that's how it works. So the plot here I brought, just it is out of interest to see how the frost potential or the frost behavior has changed, or if it has changed. So this plot here is showing the timing of the latest day each year with a minimum temperature below 2 degree at a location Nuryotpa, which is near somewhere Eden Valley. So the yellow box here on the plot is showing the month of September. And then Historical record shows that the timing hasn't changed much. Like we can have a frosty day, so a trend of only 1.35 days earlier over the past 110 years is not significant change, means it can still get frosty cold nights into at least late September. So that's quite possible. So it is not that frost for specifically for this location, but I have seen in other locations the number of days below 2 degree has decreased significantly. But again, frost is like has pockets, and there are areas where the behavior of frosting hasn't changed much over time. But what has changed here is the temperature. So now we all kind of like generally know that the temperature has increased over time. So that means we have seen, even this year, we have seen very warm winter. It was record warm winter. So what this warm condition in winter um, does to plants and vegetation, probably the spring growth is coming earlier. And if the frost potential is not changed in terms of behavior, so the new vegetation is more exposed to this kind of frost. Even the frost characteristics hasn't changed, but this is like more localized phenomena. So Bureau has like, this is not a service from Bureau. This is just an internal product. I'm just showing you the frost potential for next coming couple of weeks and almost like a month. As we are moving more in the summer months, so it is expected that we will see less number of frosty days, or the potential of seeing less number of days with frost. Then moving to surface wind, this is also another internal and experimental product. So this is surface wind forecast for next 3 months. As we can see, the red shaded area means like increased likelihood of observing above median wind speed, and blue means see a potential of seeing below median wind speed. So most of the cases we can see like it is like average condition, and in November and December like higher potential for seeing above median wind speeds. Next we move to tropical cyclone. So tropical, this is the tropical cyclone season. The long term average number of tropical cyclone per season in Australian region is 11, and typically 4 making landfall. That's the historical long term average. During El Nino, typically the cyclone number reduces for Australian region, and the first cyclone that makes landfall is also delayed during El Nino period. So then we see what the tropical cyclone long range forecast for 2024 and 25 season is telling us. So it is telling us that 24-25 Australian tropical cyclone season is expected to be like the long term average, which means 11 cyclone and 4 making landfall. The likelihood of severe or strong tropical cyclones is higher than average because of the warmer than average ocean temperature forecast for the Australian region in the coming months. So due to the rising sea level, the risk of storm surge from tropical cyclone is likely to continue to increase. So that's another point to remember. So tropical cyclone formation is rarely evenly spread throughout the season. So there are quiet period and then bursts of activities. Under the prevailing natural climate condition, the first tropical cyclone to cross the Australian coast typically occurs in late December. So long range forecast for seasonal risk is based on statistical model, which includes condition in the oceans and atmosphere over the period of July to September. So tropical cyclone outlook for week 2, 3. Now we are seeing So there is like less likelihood of seeing tropical cyclone in next couple of weeks. So that means like beside long range forecast, we also have like short term forecast as well. So this is northern rainfall onset. That's like our regular monitoring. We are seeing like if the northern rainfall season has made an onset. So this is onset date occurs when the rainfall total first reach 50 millimeter after 1st September. So it is a guide to quantity of rainfall required to stimulate plant growth after the northern dry season. And we haven't reached there fully. So then this is the Australian high risk climate hazard for October to February period. And this is a slide that we prepare for the next season, and we update this slide every week. So this is the latest slide. So this is basically the summary of what I have said so far. So there are many climate related hazards, but not all of them are equally important for each location and each season. Here we divide all our climate hazards into three categories. Increased risk presented with red arrows, near average is in yellow circle, and decreased risk in green. So increased risk for the coming season is fire danger, extreme heat, rainfall deficiency, severe storm and east coast lows, riverine flooding, and also flash flooding and thunderstorm asthma, which we have kind of seen. Near average risk is for marine heat wave, dust, tropical cyclone, and coastal flooding. And unfortunately, there is no decreased risk at the season. This is high risk weather season, so no risk is highlighted as decreased risk. So next we move to ocean and atmospheric observation. So global SST, sea surface temperature, were the warmest on record for each month between April 2023 and June 2024. July and August 24 were the second warmest on record. That means we are just breaking the record and setting the record form. So this is just falling short of level recorded in 2023, the one we have seen in 24 for July and August, but much warmer than all other years since observation begins in 1854. So quite a long record. So September 2024 is very likely to be second warmest ever recorded during September, but we haven't get the analysis yet. So what the long-term trend for temperature is telling us, it is worth mentioning. So Australian climate has warmed by 1.5 degree plus or minus from 1910 to 2023. Leading to an increase in the frequency of extreme heat events. In recent decades, there has been a shift to drier condition across the southwest and southeast in the cooler season, that means April to October, due to a combination of natural variability on decadal timescale and changes in large-scale atmospheric circulation caused by an increase in greenhouse gas emission. Then the broader climate patterns. So what are the broader climate patterns? First is the warm SST. That surrounds much of Australia. So warm ocean can provide increased moisture and energy that can enhance rainfall and increase the severity of storm, cyclone, and frontal system. But this enhanced rainfall is not like nice and seasonal rainfall. This is more like intense rainfall. Then we look at the El Nino Southern Oscillation or ENSO forecast. At this moment, El Nino Southern Oscillation is neutral in the central equatorial Pacific Ocean and tropical Pacific atmosphere. We monitor both. So the Bureau's climate model suggests ENSO neutral conditions are likely throughout the forecast period to February 2025. while some international models indicate La Nina threshold may be met in the following months. Um, even if the La Nina forms, it will be a weak and short-lived one. So the other big influence is Indian Ocean Dipole, or IOD. This is also neutral, and forecasts indicate it will remain neutral but slightly negative until the end of this year. When the IOD is neutral, it doesn't have much impact on Australian climate. Then we look at the SAM, which is Southern Annular Mode, which is negative, and it is forecast to become neutral in the coming days and become positive within the week. Positive SAM during spring typically increases the chance of above average rainfall for eastern New South Wales, while decreases the likelihood for western Tasmania. Neutral SAM doesn't have much impact on Australian rainfall, but I need to say that SAM is a short-lived influence on Australian climate, so it usually changes 2 to 4 weeks time. So what is happening in SAM? Please keep an eye on the Bureau's website for the update. Then the global context to finish my presentation. So 2024 global temperature is on track to be near or above 2023's record value. Antarctic sea ice extent tracking comparable to last year. That means very low. Many major heat waves in northern summer for Eastern Asia, Eastern Europe, and US. Very active North American fire season, and then with significant flooding in larger part of East Asia and East Africa. Widespread drought in South and Central America. I think that was all from me. Thank you.
Thank you, Janatan. That was great. I just wanted to remind everyone, if anyone has questions, please type them in now between down on the Q&A bar and just press send to send that through. I'll just going to launch that again. There has been a question come through, and as a consequence, I posted that to Janatan earlier, and she's put some slides together on frost related to that. But I thought I'd just read a couple of points from this question relating to frost. And if anyone has experience in some of these areas, feel free to make a comment in the chat or the Q&A about this. So we experienced a frost in Eden Valley on Tuesday, the 17th of September, and it was an unusual one in that none of the frost fans was able to prevent the frost damage on the blocks that they were supposed to protect. The minimum recorded was minus 3.7 degrees, and there appeared to be no drawdown of warm air, and also there was some air movement from east to southeast. We believe that the frost was an inversion frost, or what we label as a black frost, a very cold air mass moving down over the vineyards, as was highlighted on the bomb site and as Janitan's indicated this morning. There's a couple of comments here that maybe some people might have some feedback on. Should we be looking at investing in alternate frost protection systems such as sprinklers or the new Frolight system, which are lines of infrared LED lights placed at the cordon height, which provide a source of heat? I think Janatan provides some slides on the frost, and that would probably answer some of those questions, but more about the commentary around the types of protection systems that are available. If anyone's used any of those systems, feel free to drop a comment in the chat or the Q&A. In the meantime, there has been a question come through, Janatan. Some of the international models are showing a negative phase for the IOD. Do you think this will lead to the chance of above average rainfall through November for South Australia?
Doesn't look convincing to me. First of all, it's not all the models are saying the negative IOD. First thing. The second thing is IOD is a climate driver. which is the most effective for winter rainfall, and that's why IOD is so important for Australia, because it affects winter rainfall. And for southern Australia, winter rainfall coincides with the growing season, and it is very important. So winter to spring is the time for IOD development and influence on Australian climate. Beyond that, in summer, it's not that influential. Even and so we sometimes we consider, like, if it is El Nino, it will be very dry drought, but we don't know, many of us do not know that ENSO positive phase, which is El Nino, the dry thing, doesn't affect summer rainfall, so it is more influential for spring. But your question was IOD related, but IOD is more influential in winter and then spring, not in summer.
Okay. Another question relating to frost. On the slide, I think you indicated there was black frost, white frost, and I can't remember the other titles on there. Does the Bureau of Meteorology indicate what type of frost it's likely to expected, or is that done post the frost event?
I don't think that Bureau of Meteorology, because also related to the other question that you read before, Matt, it is very significant and important for grape growers, I understand. But in the Bureau of Meteorology, we are not expert on that thing. We can only forecast like when frost can occur in terms of temperature. When we see the potential of seeing temperature below 2 degree, so that's considered as frost. Because the temperature is measured at a height of 1.2 meter above ground. So when we observe to 2.2 degree, I think at that level, that means like at the ground, the temperature is 0. So that's the potential temperature. So in terms of temperature forecast, it is very effective. And even I was presenting Bureau's forecast verification, the temperature forecast can be, is verified like almost with highest accuracy. So our temperature forecast is really very good. And for some location, I think we also give frost alert, like heat wave alert, that kind of thing. But again, we really have to consider here that frost can be like very localized phenomena. Like for many parts of Australia, if I average the temperature, the number of days below 2 degree is really decreasing. But the plot I showed in my presentation, where like one specific location and station temperature, it was not changing. The frost potential hasn't changed in last 110 years. So we have to consider that too. What is like a bigger picture thing and what is like very localized phenomena. So the bottom line is like keep an eye on temperature forecast, which is good.
Okay. Look, there hasn't been any other questions come through at this point. So I would just like to thank you again, Janison, for presenting today. Hopefully everyone got a lot out of it today. And if they do have another question, feel free to send it through and I'll make sure I'll put people in touch with Janison. I'd also like to remind the audience that you will receive a link of the recording of this presentation, which you then can pass on to fellow colleagues, which will be available also on the Adabro's YouTube channel within the next 24 hours. The next webinar that we will be hosting is next Thursday, 24th of October, and this will be taking a look at the status of fungicide resistance in Australian vineyards and developing strategies for monitoring. If you'd like to register for this, please visit the Adabri website. So thank you again, and I look forward to seeing you all at the next Adabri webinar.
Thank you.
Thank you.